This is going to be an example of solving a system of equations using the elimination method. So when we're trying to eliminate, the whole point is that we're going to have to multiply one or both of the equations to get two terms that are going to be exact opposites, meaning if I add them together, I'm going to get 0. Examples of that would be 2x and negative 2x, negative 5y and positive 5y. When I add those, they're always going to cancel out. So on this one, I don't have any terms that are already going to cancel out, and none of the numbers are multiples of each other. So here's what we do. I'm going to go ahead and eliminate y, because what I notice right off the bat is that they're already opposite signs. So I'm already halfway there. The coefficients need to also match, but at least here I have one positive and one negative. That's going to be beneficial to us as we go on. So here's what we do. I have a 5 here, so I'm going to multiply the bottom equation by 5. And I have a 2 here, so I'm going to multiply the top equation by 2. Now, if these signs, like if this had been a plus, then I'd have to make one of these negative, because I always need one of them to end up being positive and one of them to end up being negative. But that's not what we have, so let's go ahead and stick here. When I multiply these out, notice that we're going to multiply every single piece. 2 times 4x is 8x, and 2 times negative 5y is negative 10y, and 2 times 13 is 26. You have to basically distribute that 2 to every term on both sides. And now I'm going to multiply the second one, and we'll see what happens here. 5 times 6 gives me 30x, and 5 times 2 gives me positive 10 for my y's. 5 times 48 is going to be 240. Yep. And so the next thing that we're going to do now is we're going to add these together. When I add these two equations, the y's are going to eliminate. Negative 10y plus 10y makes 0. It doesn't make y. It makes 0. It's all gone. So now I have 38x equals 266. I'm guessing that this is going to be 7 is what it looks like. Let me get my calculator. 266 divided by 38. Yep, 7. So we divide on both sides, and I get x equals 7. That's how we get our first variable. But remember, we don't stop there, because that's not exactly what we're trying to figure out. We're trying to figure out both. And so I'm going to take the 7 and plug it back into one of these original two equations. Doesn't matter which one. Pick the one that has the numbers you like better. I like this one because it's 13. The other one is a much larger number. So let's go ahead and plug that in. Because I know x is equal to 7, I can say that 4 times 7 instead of x minus 5y has to equal 13. It gives me 28 minus 5y equals 13. We're going to subtract 28 from both sides. Negative 5y, don't drop your negative at this point, equals negative 15. And when we divide on both sides, we get positive 3. So now we have our two variables. Again, though, don't forget what a solution to a system represents. It represents a point on the graph. If I were to graph both of these, it would be 2 lines. The point where they would cross on my graph would be at positive 7, positive 3. And so that is what your final solution should look like.